It is a privilege and also an enormous responsibility to work with children early in their mathematical experience. We get to see the excitement of dramatic changes in development over the course of just one school year. At the same time, we recognize the responsibility of ensuring that the foundations that are being built will be strong enough for all future learning. This is especially true of counting in the kindergarten curriculum. While people in society may view counting as a low-level rote skill, there are significant mathematical ideas that are foundational to all subsequent work in number, which are being laid down at this early level. Those significant mathematical ideas, the pathways by which children develop those ideas, and strategies to support struggling students with those ideas are the focus of this PD module. So how is counting foundational to operations such as addition, subtraction, multiplication, and division? Well, children's early work with problem solving typically involves counting. Initially, children tend to build sets and count them. If it's a joined situation, they'll combine their sets and start counting all over again. Every quantity in the problem is physically represented, used to act out a situation, and counted. As children continue to develop their skills through structured experiences, they begin to develop more sophisticated counting strategies for particular problems, such as counting on, counting back, and eventually skip counting. The work they do at this stage of their development supports their understanding of number relationships, which they use in turn to develop even more sophisticated strategies characteristic of students with good number sense. As we explore counting in this module, we need to begin with the big ideas that are necessary in order to successfully count objects. Typically, these principles are developed in preschool, but you should be immediately establishing whether any of your kindergarten children are still struggling with these ideas for small numbers. The first three of these principles involve the process of counting. The fourth one involves what kinds of things to count, and the last one is a put-it-all-together principle that requires students to integrate the previous principles. I should point out that children will not be able to implement any of these principles if they have no counting words. So work with the number word list or the rote number sequence, and getting that rote number sequence fluent is a subject of a later presentation. One of the main reasons we want the number word list to be so automatic is that children have a lot of coordination to do when they begin to count. They need to be able to say one number word while pointing to one object and then continue to coordinate this pairing system systematically in order to ensure that each object is counted once. In their first efforts to count, children may say some counting words while randomly pointing at some objects with no attempt to coordinate number words with objects. Learning to coordinate the number word, saying one number word as you point to one object, is a huge principle that needs to be learned. Over time, with considerable experience with the number word list through rote counting, children come to recognize the number words as having a particular fixed order. They see that order as being important to the counting process and recognize that you also aren't allowed to skip any of the number words. Counting is not a matter of merely saying counting words as we point at objects. Children need to recognize that the act of counting is an exercise in quantifying a set. In this aha, children come to recognize the importance of the last number word they use as representative of the entire set they are counting. In other words, if I count out 5 objects, I first focus on the individual objects, counting them 1, 2, 3, 4, 5, pointing at individual objects. But then when I get to the last number 5, I have to switch my focus and recognize that the 5 refers to all of the whole set that I just counted all together. Although this seems obvious to adults, it is not necessarily obvious to very young children. Typically, preschool children come to recognize some of the abstract nature of numbers. That is, they typically come to see that you can have 3 rocks, or 3 balloons, or 3 cookies, or 3 days, and that these disparate sets share an abstract characteristic that you might think of as Three-ness. What may take a little longer to develop is the idea that you can count heterogeneous groups. For example, you could count a group of toy trucks, and you could count a group of dolls, and then you could put them together and kind of rename them in your mind as toys and count them as a whole set. Children need to see that the quantity of a group remains unchanged regardless of the way in which it is counted. For example, if I have a row of 8 candies, it does not matter if I count them from left to right or from right to left. If I put them close together or if I spread them far apart. If I put them in a pile and remove one at a time and count them that way, any of these ways of counting will still result in the same quantity. This is the Order-Irrelevance principle. Counting exercises counting experiences represent the earliest foundations of children's understanding of number, and from there operations. We know that children need significant and frequent opportunities to engage in building this foundational knowledge. However, this does not mean that we should just spend the first few minutes of each day practicing. If we, as teachers, think of counting as a low-level skill, we will not give it the attention that it deserves in the curriculum, and subsequently our children will not develop the robust foundational understandings that they need to become competent in the number and operation strands of the curriculum. This will haunt our learners beyond kindergarten, as counting is the foundation for many subsequent standards. So children need lots and lots and lots of counting experience. The first thing you need to consider is how to build in extensive counting opportunities. This should include practice with the number word list or rote counting, and also counting real objects. As you will learn in later presentations, this counting experience should be combined with anecdotal observations that allow you to provide targeted support to students at their point of need, as well as recognizing when children are ready for more advanced counting opportunities. Some counting situations are easier than others. This is not merely a matter of the number of objects, but also their arrangement. For example, objects in a line are easier than objects in a circle or in random arrangements. Counting an existing set that's given to you is different than creating a set for yourself of a certain quantity and giving it to someone else. Counting groups of objects that cannot be counted individually represents an even greater challenge. For example, things that come in packages. Sequencing the counting experiences thoughtfully can support student growth and ensure that everyone is getting an appropriate level of challenge. Children also need to have opportunities to talk with one another about how they are counting. They can share, for example, their strategies for keeping track as they count large numbers of objects or a random arrangement. In their article, Counting Collections, Schweingruber and Chan state this quote, "We also find compelling evidence that the children learn a great deal from one another's strategies." End quote. This capacity for children to learn from one another relies on building effective discourse opportunities into your classroom. Early work in counting should go beyond rote and include opportunities to engage in counting sets and combining small sets so that they can see how counting can be connected to additive and subtractive situations. And you should be able to do that at kindergarten before even any formal discussion of the words addition and subtraction. Plus or minus. Before this formal knowledge comes situations that they can make sense of, which we as teachers know are additive or subtractive, but they can learn about the experience before getting the formal jargon. For example, you can count children who wore tennis shoes to school that day and the children who wore a different kind of shoe. 2 sets, then you can combine them together and say, how many are we all together? And rename it and count that. The situation is additive, but you don't have to use those formal terms yet. Children use their counting skills to handle the situations. Eventually, this foundational skill of counting, along with the informal experience that they have with additive and subtractive situations, will prepare them for subsequent mathematical work in operations. As you can see, quality preschool experiences both at home and in school settings can and should support learners in developing some of the foundational understandings about number, such as cardinality, as well as skills and numeral recognition. It won't take you long working at the kindergarten level, however, to recognize that not all children arrive at kindergarten having mastered these experiences. However, it is also worth noting that research, as reported in Mathematics Learning in Early Childhood, has documented what it calls, quote, considerable variability in the age at which children do particular numerical tasks, end quote. Therefore, we will be spending time on these foundational concepts in this kindergarten sequence. Later in the module, you will find assessment tasks that can be used to identify children early on who need support on these foundational ideas, even with smaller numbers. Those students who enter kindergarten having met pre-K benchmarks for cardinality, one-to-one correspondence, written numerals, and the number word list for small numbers will not necessarily realize how these skills can be extended for larger numbers. This becomes a major focus for the kindergarten curriculum in number, extending the numbers that they have these skill sets for. But there's also a new advance in the Common Core curriculum, something new on their horizon, and that new advance is the capacity to comprehend numbers in the teens by thinking of them as tens and some ones. Notice we're not merely talking about them learning a rote sequence. They're expected to truly understand and comprehend those quantities and be able to think of those quantities as a 10 and some ones. This understanding is significant, and it cannot be taught in one lesson. Likewise, one cannot assume that children have this understanding simply if we just train them to point to the one part of the teen number and say, this is 110, and then point to the ones digit and say, this is 3 ones for the number 13. Being able to just be trained to point and say something like that doesn't mean that they understand it. Understanding how teen numbers can be decomposed into a 10 and some ones will follow from understanding how smaller numbers can be decomposed or pulled apart. In other words, you must have part-whole understanding of smaller numbers in order to be able to have good part-whole understanding of teen numbers. The authors of the Common Core have used the word focus to refer to how standards within a grade level are related to other standards within a grade level. And here we have a couple of examples of focus. This particular understanding of teen numbers in the counting curriculum is also related to the standard 1 under number and base 10 for kindergarten, which addresses decomposing numbers in the teens, and also to the third standard in the kindergarten operations and algebraic thinking, which talks about decomposing numbers smaller than 10, a prerequisite to being able to decompose the teens with understanding. As you can see, there are some big ahas on the horizon for kindergarten, and it's important that this be done well so that they have a foundation for their